So now we are going to make a for loop for our ROIs. The only thing we need to know to set up a for loop is the total number of ROIs on the list. We can get that information using ROI manager function with the option string as count. This will return the number of ROIs in the ROI manager list, so we can store the number on the variable named as all. And we can set up a for loop based on that information. And inside the for loop, we will check if each ROI is positive to green or red or both markers using the red and green mask we have generated previously. So how can we check the positivity? Well, ROI list is essentially the list of selections. When we click an ROI from our ROI manager, this will create a selection on any active image window. This is the same as the selection created by drawing tools, but just generated automatically via Analyze Particle. So when we select a ROI on a mask image, this will create a selection, and if there is no cell, the intensity measurements we get from this selection will be 0 for the average intensity, minimum intensity, and the maximum intensity. And even the area fraction will be 0 as there is no white pixel within this selection. But then if there is a cell, the average intensity will be 255, which is the value for the most white color in 8-bit image. And the minimum and the maximum intensity will be also 255, and the area fraction in this case will be 100. If the cells are ending up sitting partially on our selection, the average intensity within this selection will be somewhere between 0 and 255, and the minimum intensity will be 0, and the maximum intensity will be 255. And the area fraction will be also somewhere between 0 to 100. So depending on how we want to define positive cell, we can utilize different measurements. For example, if we want to define this cell as negative and the rest as positive, we can set the condition for negative to be the average intensity equal to 0, and for positive, the average intensity is above 0. Or we can also use maximum intensity measurements, or even use the area fraction measurement. And in this case, we can just set up the criteria with one of these intensity measurements. But sometimes we may want to set the criteria more strictly, so counting this partial group also as a negative, then we will have to change the criteria so that if we are using the average intensity, positive cell should have value equal to 255, and the negative cell should have value less than 255. Or if we are using the minimum intensity, positive cell should have value equal to 255, and the negative cell should have the value equal to 0. If we want to set this partial group separately, and if we are going to use the average intensity, the positive cell should have value equal to 255, and the negative cell should have the value equal to 0, and the partial group can be placed in else group. Or if we are using the area fraction, we can set the value even more specific. So there are many different ways to categorize groups based on our needs. In this example, we will use the max intensity value and count every cell that has any signal as positive. So going back to our ROI loop, we will first select the red mask image and activate the first ROI selection using ROI manager function with the option string as select and specifying the index as A. This option will select an item in the ROI manager list, and the ROI index will start from 0, so we can use our loop counter A as is. Then from that selection, we will measure the max intensity. So let's find out how to grab the measurement. So far, if we wanted to get some measurements from image J, we have first set the measurements via analyze that measurement, and then get the result from the result table via analyze measure. And this will be the recordings from this step, and it can be very long if we wanted to measure every type of measurement. And getting the value from the result table is done using this getResult function, where we have to specify the heading of the measurements and its location in the current result table. This combination works as it is, but the set measurements line can be too long, and also for the getResult function, we need to know on which row our data is located. So this can be quite complicated and lots of things to think about. This process can be simplified with a function called list.setMeasurements. List.setMeasurement function will measure the current image or selection and store the result table column headings and the measurement values into the list. With this function, the values will be loaded into the list and not on the result table. And this list will be stored in the memory, so we won't see any result table or any list. Also, this function gives data to the memory rather than returning back to us. We don't need to set any variables for this. And then to grab the measurements that is stored in the list, similar to getResult function, we can use the list function called list.getValue with the key inside the bracket. This function will return the value associated with the key as a number. And in this case, the key is the column headings of result table. So essentially, once we run this list.setMeasurement function, and if we want to grab the max intensity value, the heading of the measurements in the result table is max, so I can put this string and store the value into a variable named rmax. So this is how we can write. Within the ROI loop, we will select the image, then select the first ROI, measures the selection, and grab the max value. Then we will do the same procedure on the green mask by selecting the green mask image, select the same ROI, measures the selection, and grab the max value and store into a different variable named as gmax. Now we have the max intensity measurements from both red and green mask image. We can set up a comparison condition that if both max intensity is above 0, we will increase value of our counter named as both. So in our example image, it will be the first cell. Then set up a else if condition where the red max intensity is above 0, but green max intensity is 0, which is red positive cell like this. We will increase value on our counter named as red only. Then set up another else if condition where the red max intensity is 0, but green max intensity is above 0, which is green positive cell like this. We will increase value on our counter named as green only. And having this counter means that we have to define these variables somewhere beforehand. And we will initialize this counter outside our ROI for loop. Now coming back to our if-else condition. If you remember, we also wanted to make a proof image with different colors. So we are going to start from 3 empty images named as both green only, red only. And whenever the ROI meets the criteria, we will fill this image. For example, if the ROI meets the criteria for double positive, we will select this image named as both and activate the ROI selection and fill the selection. This fill command can be recorded via edit fill. And we will do the same thing for the red only and green only group. So this is the refined code. And also we have to create those 3 black images. To create a new image, we could have used the new image function. But to do this, we also have to define many things like title, type, width, height, and depth. Also, this newly created image will not have the same metadata as our image, such as pixel size information is missing, so we will have to define it if we use this new image function. So I usually use the image calculator by subtracting any image to its own and have the result image created using the create new window option selected. In this way, the new image will be the same size and the scale information will be also copied, and only the intensity of the image is all 0, which is black image. So I will rename this image as both and duplicate this with the new title as red only and again with the title as green only. and the recorded code can be cut and pasted to our script. And similar to the counter setup, this process should be done before the ROI for loop starts. So this is what we have done so far. I've already gone through this line 1 to 31 and this line 32 to 55. And so after we have added every cells to the ROI manager, we can set up a for loop, but we can now have a bit of preparation for what we are going to do inside that for loop. So before the for loop, we will make 3 new black images using image calculator and duplicate. And then we can also initialize our counters. Then when we go into the for loop, on each ROI, we will check if it is positive to red or green by measuring the maximum intensity from the red mask and green mask. And using that measurement, we can set up 3 different conditions and generate the proof image and increase the counter. When the ROI loop is finished, we will have the value of these 3 counters to log into our table. We have already created a table named cell counting at the beginning, so we can select that window and define the column and the value using table.set function. This function assigns a numeric or string value to the cell at the specified column and row. So on the first column, we will set the image name and the row will be matched to our image loop counter, which is I. And the name of the image can be list box bracket I. On the second column, we can put the total number of cells, and for the value, we can use the total number of ROI from the ROI manager. So the name of that variable is all. Then on the third, fourth, and the fifth column, we can add our counter for red only, green only, and both. After we have set these values, we have to update the table to see the changes, otherwise the table will remain empty. So when we run this, the table will be updated like this. And once the for loop is finished, we will have our table filled with more data. Then at the end, after we finish the loop, we can save this to our out.dir. In ImageJ, table can be saved as .csv format by using the saving format as text.txt, but the naming the file as .csv at the end of the file name. Then, as a last thing, we can now make a proof image. In this example, we will combine two images literally. One is the raw fluorescence image, and another is the ROI drawings which we have created during if-else statements. We can first merge red and green channel using image color merge channels. We will select the red channel image to C1 and green channel image to C2. Then we will use the create composite option and keep the source image. And we will make the result image into RGB image via image color stack to RGB. And then we will rename this as raw image. Then we can draw a white line around the image to make a borderline. To do this, we can create a selection for the entire image via Edit, Selection, Select All, and draw a white line via Edit, Draw. We can also merge three drawing images by matching color as we like. We will set the red only mask to red color, which is C1, and set the green only mask to green color, which is C2, and set the both mask to yellow color, which is C7. Then we will also use the create composite option and keep the source image. And we will make a result image into RGB image via image, color, stack to RGB, and rename this as circuit mask. Then we can also draw a white line around the image to make a borderline. We can create a selection for the entire image via Edit, Selection, Select All, and draw a white line via Edit, Draw. Then we can combine these two images via Image, Stacks, Tools, Combine. And select the stack 1 as raw image, and select the stack 2 as circuit mask. Once we have this combined image, we can save this as PNG format with the file path as outdir plus name only plus dash proof string. So this is the last part of our code where we have logged data onto our table, then make a proof image. And we always need to clear up workspace and memory and finish the loop. And when all the processes are done, we can then select the data table and save it. This is the end of day 4 for macro writing workshop. there is only one activity left for you to do, which is completing this example by yourself. Thank you for your attention.